Okay, next up we have a calculation chemistry question. Okay, so if we are given the fully balanced equation, the net ionic equation, the volume uses 0.1 of silver nitrate to titrate bay water samples in March. So for the March sample, they use 7.3 milliliters. For the April sample, they use 4.46 milliliters. Using the balanced equation, calculate the average number of moles of sodium chloride in each of the titrated samples. Calculate the average number of grams of sodium chloride in each of the titrated samples. Use the balanced equation to calculate the salinity in parts of each of the samples. It can be assumed the density of bay water is 1 gram per milliliter. So let's just get into it. We know that because of the balanced equation, the ratio is 1 to 1. So if we have the moles of sodium nitrate used, we can find of silver nitrate used, we can find the moles of sodium chloride that we need because the ratio is 1 to 1. So we proceed by finding this. And the moles of AgNO3 are going to be equal to 0.01 multiplied by 0.0073. So this is for the March sample. And this will give us 7.3 by 10 to the negative 5 moles. And that would be the moles of NaCl for this March sample. For the April sample, we're going to use 0.00446 and we get 4.46 by 10 to the negative 5 moles. April sample. Okay, on to the next question. We want to find the average number of grams of NaCl in each of the titrated samples. And so we know that we need is equal to mass over molar mass. So mass, of course, is equal to moles by the molar mass. Let's just put that down. So for the March sample, we will have 7.3 by 10 to the negative 5 multiplied by the molar mass of sodium chloride, and that's going to be 58.45 grams per mole, and of course this is in moles, so the units cancel, and we get 4.27 by 10 to the negative 5 grams. For the April sample, 4.46 times 10 to the negative 5 moles, again by 58.45 grams per mole. And this is going to give us 2.61 times 10 to the negative 5 grams. And those are our two answers. And lastly, let's move to part C, which is the salinity. And so the salinity is going to be the mass of NaCl over the milliliters titrated. Remember that from March we had 4.27 times 10 to the negative 5 grams. From April we had 2.61 1 times 10 to the negative 5 grams. And this corresponded to 0.0073 liters, 0.00446 liters. And so we're just going to plug that right back in. And so for the March sample, it's going to be 4.27 times 10 to the negative 5. Sorry, this is supposed to be negative 3. That's just an error in my writing. Over 7.3 milliliters times 1 gram per milliliter. And this is also in gram, times 1,000 milligrams per 1 gram. And this should give us 0.585 milligrams per gram. And we should get the same answer for the April sample. This is also supposed to be to the negative 3. So 2.61 by 10 to the negative 3 grams. All of these is just for the sake of units. That's just so that we get milligrams per gram. So over 4.46 milliliters times, and again, and we again get 0.585 milligrams per grams, which is the same thing as this. And this is our final answer.